Hello, everyone. I'm Pedro. I work in Accenture in Recife. Today, I'm going to present you this case. It's a work in progress as well. Document reader using deep learning with a small data set. This is going to be our outline today. Introduction, a brief background, and some of architecture, small data, the problem of small data, and the deployment. Well, the goal of this project is to automate the process of getting information from documents. So the user has no need to input the information. You extract it directly from the document. And we developed the solution to achieve this. It's a really brief background, as you may know these concepts. Artificial intelligence is a computer-science field which tries to create intelligent algorithms, intelligent machines. The machine learning field is a subfield of AI. And it tries to learn from the data without directly explicitly programmed, And computer vision is another field where the main purpose is to extract information from image or sequence of images, aka videos. It comprehends from simple processing algorithms, image processing algorithms, to the most sophisticated deep learning algorithms and architectures. Neural networks, you might know about it. It's slightly inspired in human brain. The basic structure is called neuron, and it basically combines the input and applies an activation function, usually nonlinear. And then you have you can combine a lot of different layers of these neurons to implement a neural network. And deep learn is mainly based on neural networks, but it's like extension. Nowadays you have a lot of power of computation, and then you can go deeper. So you can have a lot of layers and different architectures to solve the problems. Convolutional neural networks are specific architectures of deep learning that work really well with images, and it automatically extracts important features. So it has this main concept of convolution, which essentially are filters that extract information of the data. Here, the images. The good thing about it is that it learns these filters from the data. So it does the job of extracting information, the right information to perform the task. LSTM, it's another architecture. It's based on recurrent neural network, and it deals well with sequences. It has mechanisms to address the sequences in a short term and a long term, and it works really well for text sequence prediction. And then we use these concepts and the techniques of these areas to solve our problem of document reading. The approach we have made is using object detection. The object detection is a computer vision task that you try to find some objects, localize some objects in the image, and also you can classify those images with confidence level. And the state-of-art techniques are using CNN-based models. And the classical OCR is an algorithm or a system that tries to recognize the digits, the classic MNIST database, for example, to try to recognize them, and they can be solved with neural network And nowadays, there are a lot of works using LSTM or other recurrent neural networks to address the problem of the sequence estimation, and it improves the performance of the OCR. So this is my driver license to illustrate this architecture. There are two main components. The first one, you have a detector module where we find the fields we are interested in. For example, there we got the name, the personal ID number, the other personal ID number, and the driver's license number. And then you go to content recognition, which uses a model with LSTM and inception. Then you get the information from these images. So we divide the problem. First, we recognize the fields, and we classify them. So previously, we know what are those fields before the content recognition. So we can tweak the content recognition to address better with these fields. Actually, what we did, we separated, we divided between numbers and names. We had more difficulties with the names. The problem here is that we had few images. So our data set had only 700 images. So it's not enough for a huge model as the one we were using. It's difficult to get more information, so in the case of the document, they are sensitive information, and usually the client won't be giving you much of this information. And deep neural networks can have a lot of parameters to train. That's a problem. So you have small data and you have a lot of parameters to train. That leads to overfit. So you have some ways to solve this problem or to address this problem. That is more training data. That's not our case. And regularization, it's a usual technique to try to solve the problem of overfit, and data augmentation. That's what we did. So we had used for the first module, the object detection module, some usual data transformation. So we applied Gaussian blur, we applied Gaussian noise, brightness transformation, dropout noise, and others. These techniques were applied to the object detection model, the first one. So data augmentation had improved the performance. This is an example of a car document, and this is just one example of transformation. This is a piecewise affine transformation that simulates like the paper was like folded. And besides that, there is some dropout noise. I don't know if you can see it in the presentation. This is another case where we try to simulate low light situation. So we dropped the brightness, we reduced the brightness, and also we applied Gaussian noise. So usually when you have low light situation, the sensor of your camera increases the ISO sensitivity. So it gets more sensible and it gets more noise. So that's a simulation of low light. And for the LSTM, you had another problem that was we have to create more sequences. We have to generalize well on sequences. So we had to create more data, create more sequences, different sequences. What were synthetic sequences, and create generators for each of those fields, and And then we used imaging painting, so we extracted some backgrounds from the original data. And we used imaging paint that is a technique that tries to reconstruct the background. So you remove information of the image, and then you apply imaging painting. It tries to reconstruct the background. So we had to remove the original name, for example, of one of the CNH of these driver licenses. And then we apply imaging painting to recover the background, so you can apply over this background a new sequence, a new generated sequences. And then we generated a letter, and for each letter we generated a symbol and an image for to create the new sequence. And then we created fake generators, and then fake generators are input for this this process of like pasting over the background, which was recovered with imaging painting. So these are some fake fields. These are completely random generated. Actually, we had a list of names, random names, and we then combine these names and apply over the background. So that I think you can't perceive that there was another name there, and we had like removed that name and put another random name in it. This is very simple, like it's a prototype yet, so we are working on it yet. So we just deployed on EC2 from Amazon, and then we use Docker for environment setup, and we use just a simple web framework, Python Flask. I think you might know this. Just to implement a really simple endpoint to simulate this, to make a demo for our clients there. I think that's pretty much it.
So the object detection model, how did you manage when you make the transformation, you distort the original image. So how do you keep the bounding box between the right parts of the image? Did you have this problem? How was it?
No, actually, I don't know if I understood your question, but actually we use object detection like to crop the image. So this image is going to be the input of the other module. So we enter just with the image to the next model, and it tries to extract the information. So we are using a textual OCR. It's available in TensorFlow GitHub as a research project, and it gets no localization information. It tries to get the whole image, and it extracts the text in there.
I see. Let me reformulate.
Okay.
So you created bounding box for detecting regions of interest in documents, right? When you apply some transformations, you distort the image.
Oh, okay. Okay, yeah. We have to keep track of this.
I see.
Yeah. We apply transformation we try to create a mask for these bounding boxes, and all the transformations we apply to the image itself, we apply to the mask.
I see.
And then we recover the bounding boxes.
I see. Thank you.
No problem.
So, hi. Two questions. First is how big got your training set and test set after you synthesized the data for the models? And how precise was the model before and after the synthesized data was added?
All right. The final data set had about 5,000 instances of images. 5,000 instances, and before the augmentation, we were giving next to 60–70% mean average precision. That is the metric we used. So after that, we had next to 95, something like this, for the object detection model. For the sequence estimation, we had a lot of improvement. In numbers, we have next to 95% for numbers. For names, we still have some problems. It's near 75. So we are trying to improve this.
Nice talk. Have you used how you deploy the model? Do you use TensorFlow serving or other project to deploy the model?
No, it was really simple because we were just trying to make a demo. So we used just TensorFlow as is and Flask, and we didn't use a framework for deploying, actually. Just use TensorFlow and Flask, basically.
Hi. What's the business purpose to replace the background? Wouldn't be a fraudulent process?
Replace the background. Actually, it was just to improve the model performance. We had to do this because we had small data. So we had to increase this database so we can overcome the overfitting problem that was transparent for the client, for example. It was internal need.
Hi. One question I have is, have you tried to use pre-trained models on other data sets to see if you could transfer the weights from other data sets?
Yeah, we had tried to do this, but we had no improvement. Usually the pre-trained models are trained in ImageNet, Coco, so the domain is really different to documents. So we had not improvements using pre-trained model.
Hi. As far as I am concerned about the first part of the model, you extract a mask of bounding box, right? And then you read the sequence of numbers or letters, names. But my question is, what is your final output? In a matter of fact, this is structured data. Like I give you a driver license and you get me like a CSV of structured data to pass to someone that is not techie savvy to deal with this raw data or something like that.
Yeah, it's like this. We get the image, we crop the fields, and we go to the next model. It extracts the text, and we know the fields, which are the fields, and we know the text for each one. So we return it as a JSON.
Thanks.